All right. So, what are some things about programming, like some, I don't know what they call, like little like statements about like, you shouldn't do, like just some like rules about like programming that you've heard of to like make sure your code is good.
Don't repeat yourself.
Don't repeat yourself. Yep, that's like the biggest one, but there's like write pure functions, make sure your functions are slim. They only do like one thing at a time, things like that. But there's another thing. Has anybody heard of decoupling or coupling before?
I think Chad went over tightly coupled, what that means.
Okay. And did he mention like whether that was good practice or bad practice?
Yeah, tightly coupling functions is not good because you want to be able to kind of make them more independent and not so dependent on one another. That way you can reuse them, is what kind of along the lines of what he was saying.
Yep, exactly. So if you already went through this, it's fine. It's just a quick review. So if I were to write a function that was tightly coupled, such as, I'm just going to copy some code. And so if I created a method, this could be a class as well, or just any set of instructions. I've got this make API call and write to a file. So this imports some made up either method, it could be a class, an object. So it imports some HTTP request method. And that's the name of this method, HTTP request, and also file writer. And in this function, it executes this HTTP request method, or this object or class, and it has a get method onto it, and it passes in the URL that we pass in as an argument. Then we get some result back, and then we take some data. So we take the result from that, and we do result to string. So maybe we take this and take the data and turn it into a string. And then we run this file writer method or object, and that has a write method onto it. And we pass that data in, that turns it into a file object. So it writes to that file, and then we just close that file. This is a tightly coupled method because one, we can only use this HTTP request class object. Same with this file writer class or method or whatever this is. This is just like made up an example. So this function only does one thing, but it's not very robust, as in it can't do a whole lot because it relies on this specific method and this specific file writer. It's almost like how we were doing yesterday when we were calling, when we talk about composition, we'd have like a class. What would we have? Tree or oak, like an oak tree. And then we have the dunder init, self, and we had like self dot branches or branch, and we would instantiate a new branch method. So here again, pretty tightly coupled because every time we create an instance, we also create a branch method. And maybe there's a bunch of different type of branches out there. Maybe there's I don't know, just different type of branch objects out there instead of just this little branch, this specific branch object. So this is also like a tightly coupled and this is also tightly coupled. Now, to decouple, make files a little more robust and a little more dynamic, And because maybe we don't want to always use this HTTP request method or function or class. Maybe we want, there's different types of HTTP request libraries out there or something. So in order to decouple this, to make this not so reliant on this specific function or this specific class or this specific module or this, we can just import, we can actually get rid of those. And we can say like HTTP request, and this can be any type of HTTP request, class, module, etc., and file writer. So we're decoupling this function. So let's actually go back. Just copy that down. So we end up passing in those as arguments. So we don't actually have to. So we're decoupling this method. So we're not reliant on this specific class or whatever. We can actually pass in whatever object we want or method we want. But these methods specifically happen just the way this is written. If we pass in, so if I do like import HTTP, like that one, or maybe just the request library. So maybe these are two different modules. So like it'd be like from request. I don't know if this is import the request method from HTTP request, import the HTTP request method or class. There we go. So when I, instead of here, I'm only utilizing one class and I have to use that class all the time, but maybe I don't. Maybe I want to use this request method or this request method. So when I end up calling this make API call write to file, I can use the like URL www.something.com. I can pass in the request class and the writer class, or I want to pass in the HTTP request method and like a file writer class. So this is where I'm decoupling, like a decoupled method. So it's more dynamic, doesn't rely on anything else. Any questions on decoupling? And what this is actually called, it's not just, this isn't just a decoupled method. This is what is called dependency injection. It's called dependency injection. This is how you decouple things, is by doing dependency injection, because we do rely on some request method, something that we pass in. So we're injecting a dependency into the method or class or whatever.
Quick question.
Yep.
Would this be the same thing as us declaring the variable in the double init statement and they just put in their own value?
Yep, exactly. So just like this. So right here, this is tightly coupled. If I wanted to do dependency injection, dependency, I can say, type in a branch, and then that this branch instance is going to equal that. And then I have some class branch or some branch There we go. So here I've got a branch class, I've got another branch class. And so when I create the new instance of an oak, I can say oak and then pass in a branch instance or another branch, the other branch instance. So now this oak tree can have multiple branches on it, different types of branches on it. So that's where it's dependency injection. So where we're not actively invoking or instantiating these branches. So just like what we did with apple trees, how I was injecting, or it was coupled with an apple, maybe an apple tree, well, it wouldn't be an apple tree, but maybe the tree can produce any kind of fruit. And we have an apple instance, we have an orange instance, we have, cherries, whatever, pumpkins, whatever. I don't know, I guess pumpkins wouldn't work. But so, and we'd have to pass those instances directly in. So
Not the pumpkin, huh?
yeah, a pumpkin tree. Like any fruit. So like instead of having it specifically, so like this tree, it might like have a class or def dunder in it, self, there's, I don't know, fruit, and that's like a Boolean value. And maybe if like self dot bears fruit equals just so happens to be true. So if this is defaults to true.
Spell true wrong.
Yep, thank you. And it's like class, or I'm sorry, def add fruit to tree, fruit, instead of just like appending self dot fruit equals an array of fruit instances, instead of it having been like self dot fruit append, create a new apple instance like I was doing before. So this is coupled. Instead of, if I wanted to decouple it, do dependency injection. Instance. And then I pass in a fruit instance. So adding the fruit to the tree doesn't have to rely on an apple anymore. So this is a little more dynamic. So I don't have to go around and change everything. So this tree can handle any type of fruit. I can add apples to this tree, cherries to this tree. Hell, if I want to, I can add pumpkins to this tree if I wanted to. All right. Any questions about dependency injection? Yeah. So with that, I just kind of also want to show you with dependency injection, there could be a different way of, there is a different way to actually, so this is all in your materials for today. But when you're testing, writing unit tests for methods such as like here, so if I was going to test this tree class and write unit tests to make sure that, hey, this does have like a fruit instance in here, this is pretty much very similar to kind of what I did if you want to read through it. But like we have a driver's license application class that takes in a license type. We have a local DMV class, and we have a DMV and employee. So we have a local DMV, an application, so driver's license application. And in here, this driver's license application, this is decoupled using dependency injection. It has a method called submit application that takes in a local DMV instance. And that local DMV instance also has an add employee method that takes in an employee instance. So, which is this employee class. So if you wanted to, again, loosely coupled classes and programming, typically if it's here, if it's coupled, you only have to call one class once and it automatically calls the other classes because it's tightly coupled, because one class has a method that invokes another class, that invokes another class, etc. So it creates a bunch of instances by just invoking one method. But with dependency injection and loosely coupled, you have to create instances before and pass those instances into methods. So to get it up and running, first, you have to create instances of each and then pass those instances into those methods. So like to get it up and running, like your runner code, there might be a little bit more, it's a little more complex and there's a little bit more you have to do, but it's not that difficult. It's pretty straightforward. But what I want to talk about is testing these. So with the add employee method from the local DMV that takes in an employee instance, if I wanted to run a unit test that tests this add employee, I need to create an instance of an employee in my unit test. But instead of actively creating an instance of an employee in my local DMV unit test, there's this patch method inside of the unit test library that creates a fake instance of a DMV employee class. So we can run with patch. So create a fake employee. And this is the file, the path to that fake employee. So as a fake employee instance, and then I can update the attributes of the fake employee instance, such as name and specialty. That's what I'm updating. And then I can just add that fake employee instance into this add employee method to test the add employee method. So it creates a fake instance of that employee instance. Same with if you want to make sure a specific method is called, like DMV, where is it? So like that fake employee instance has this thing called process license, which takes in an application. And I can do the same thing. So create a fake application instance from the driver's license application class. And I can also, as I'm doing with here, I'm creating a fake employee instance. And I can test to see whether or not that fake employee instance runs that process license method right here, like so. So just testing could be it's just a little bit different when you're testing those. And the main thing with that is just how to create fake instances of the classes that you're injecting into the local DMV or whatever class you're doing a unit test on. And you can also test whether or not methods are called during when you're running like this add employee calls fake employee. So where to go? Add employee. Add employee. Once I add that employee, I can run this process license. So this just makes sure that, hey, if I fake employee run that process license, make sure I can actually call that. Questions about dependency injection?
Many, but I'm gonna stick with one. So just for clarification, is that similar to whenever we write unit tests and we create an instance of it in the unit test and we assign it to a variable, but you're saying we don't want to do it that way, but is that similar to doing that?
So what you are doing, you are actually, so for this specific unit test or this specific test, we're testing the local DMV class. So we're testing this class, and this class depends on the employee class. So we're injecting an instance of an employee. So with that, if we're testing the local DMV class that relies on another class to inject into like a method such as add employee, in that case, we're creating a fake instance of that employee, but we are still creating a real instance of the local DMV class.
Okay, I see.
Yep. Yeah.
Okay.
I have a question about.
Oh, I'm sorry.
No, go ahead.
So basically, if I understand this correctly, instead, the benefits of not creating an instance would be we wouldn't have to type all those self dot statements all over again. It'll create the whole thing for you.
Yes, like so for here, we would have to import, so from DMV employee, import DMV employee class, and then create an instance down here, like right here, like create an instance of an actual DMV employee. But with here, we're not actually creating a instance. I don't want to say we're not actually creating, because we might be, we actually don't know. I think we are creating an instance of an employee here, but it's like a fake employee instance that the unit testing library is doing for you. So instead of actively creating a self dot employee by doing DMV employee instance, like we would up here, like we are doing for the local DMV, this is doing all that for us right here.
Okay, that's what I thought. Thanks.
Yep.
So right there where you have your with patch.
Yep.
It's and your quotations there. Is that just from the example, like the DMV employee is a class that we're going to use, and would one of those be the file name and one of them be the class name in the file?
Correct. So this is the file name and this is the class name.
Okay.
So if we have, yeah, so like DMV employee dot, it should be .py. But yeah, this is all, and there's other ways to do this patch. You can also use it as a decorator, but I encourage you to look at the documentation for that. But just know that when using dependency injection with multiple classes, that writing unit tests is a little bit different. There's just some additional syntax that you kind of have to add or read about. All right. Any other questions?
Hey, Tom, is it safe to say that the with keyword with patch, is that kind of the same as if you were doing file
CSV.
operations, and it just ensures that it's closed when you're done with it, so it kind of keeps the test rolling forward without bogging it down?
Yeah. Yeah. So yeah, you'll start seeing this with starting Thursday and Saturday with working with CSV's files. All right, let's keep going. Let's talk about args and kwargs. We kind of already reviewed this, but let's just review it again. So when we want to do pass in multiple parameters or arguments in a function that we might not know, such as like add up, or yeah, like add up to, and maybe we want like num1, num2, num3, num4, all the way up to as many numbers as we want. We can do that by using arguments. So like maybe we don't know how many arguments are going to be passed in. So we can use the args keyword, that using the dollar or the star args. And this passes it in. Is it as a tuple or an array? I can always just print args like so. And if I wanted to, I can say print add up to, and pass in like 1, 4, 6, 9, whatever. If I wanted to run that, I can do Python args kwargs. So yeah, it passes it in as a tuple like so. So you might see some things like it needs at least 2 numbers. So num1, num2, and then args like that. If I did that, now it's just 6, 7, 8, 89, and 4, because 1 and 2 correspond to 1 and 2, or I'm sorry, 1 and 4 correspond to the first argument passed in and the second argument passed in. So if I want, I can actually do like, hey, if length of args is greater than 0. Let's say like answer equals num1 plus num2. And then answer plus equals for num and args. Add in that number and then just return answer. If I ran that, I get 111. So you can check with whether or not there's arguments. Any questions on using the args?
That argument could be whatever word, but does the star, just using the star work?
So I can do nums. No, because you still need to define what that is, what you should call that tuple. But you can call it whatever you want. It's just typically called args because it's arguments. But you can call it star and nums. Again, it's just a named variable of what you're calling that, what you're passing in.
Okay, I'm only asking because I think I've seen that star somewhere.
Yep.
Where it was just by itself.
Okay. Yeah, I've never seen it just passed in a method by itself.
It was there was a star by itself in the spec files from last night when it was just importing everything,
Oh,
all the classes from a file. Maybe that's where.
yep. So if you just see the star, like from some file import star, that's like saying, hey, everything from this file. Yeah, import everything.
Yep, that was it.
Yep,
Thank you.
Cool. Yep. All right. So you'll see audio.
I have a quick question.
Yep.
When we, like, for instance, the apple tree file, when we imported the apple tree file, since we imported apple to apple tree, did it come up, does it come over with the apple tree file?
So when it would be like from apple import apple or tree. So it'd be like apple tree. So this would be the correct way to import that. But if you had multiple classes or methods, you can just apple tree. You could have done that as well. Now also would have worked. I don't know if
Okay.
that was your question.
Yeah, so basically you're telling me if an import is already in the file and I import that file to another file, it brings the import over with it?
Oh, no, not necessarily. Oh, no. So if it's like a nested, so in this file, this imports apple tree and then apple tree imports apple.
Correct.
I wouldn't assume it does not. No.
Okay.
So I wouldn't be able to access apple in this file if apple was imported into the apple tree file. No, I would have to use, I also have to import apple. All right. So we have args using just the star. And that passes in as a tuple. There's another thing we can do, which is kwargs. Kwargs is key word arguments. Did I spell that wrong? I don't know. So this passes it in almost like an object. So I can say like define get employee info. And maybe an employee info has a bunch of different different types of things possible values on it. So here, if I wanted to pass in employee info and just like print all, let's just say like for, I'm actually going to call it as kwargs because you'll see that. So for item in kwargs, I'm going to print the item. And this passes in things from a dictionary. So if I had like Tom equals name, I'll just say like Tom Preet, age, what else? Occupation, something like that. I don't know. And this doesn't have to be a string. And I wanted to pass that in. I can do print get employee info. And then just instead of passing in Tom like so, let's see if this works. Probably doesn't, because it takes 0 positional arguments, but 1 was given. I need to make this dictionary a keyword argument by doing the stars, the double star. And there we go. I get name, age, occupation, none. So that's the item. But if I want all the like values, I can key kwargs.values. So for value, print the value. If I did that, I get name, age, occupation. Now I get the values. And if I wanted the items, same thing. So for item dot items, or I guess I would say like key also does the same thing. Oh, sorry. The items returns the tuple. So item, that's a little more right, like for key. So here, if I wanted to print that, can do like an F string item or item index 0 item index 1. There we go. Name, age, occupation, etc. So you'll see this keyword arguments occasionally as well. So with this, I'm literally only passing in a dictionary, but I'm converting those into keyword arguments. What that looks like is saying like name equals Tom Breed, age equals 35, occupation equals software developer. That's what that's doing. So it doesn't matter the placement.
In that, can you have multiple keyword arguments? Could you add in more dictionaries?
Say that again.
Like when you do the args up there, you're able to put in as many as you want. Can you do that there? Could you list more dictionaries?
So
Like if you
like-
call that function, could you plug in 2 dictionaries down
oh,
to have
like
it available?
like another dictionary, like so.
Right, and then when you call get employee info, you plug in Tom, Sarah.
That's good. I don't think so. Let's just see. Yeah, I don't believe you can. Yeah. So with keyword arguments, it's just you just pass in one as a dictionary, but it's just easier to decouple or not decouple, but like extract. If you don't know how many keys are on whatever your keyword arguments, it could be like a more keys. Then you can do something with that. So you'll see sometimes where like args like something like this, you might see something where the args gets passed in first, and the very last thing is the keyword arguments. So you might see that in some of the syntax, but it's not. You probably won't be using that a lot in the program, but just know that what these do, what that syntax looks like. Any questions on args and kwargs? Nope. All right. Well, with that,